If I'm asking you to divide by 2x minus 3, you can't use this trick. But if I'm asking you to divide by x plus or minus a number, you can. I'll do an example of when it works. Okay? Example. I'll make one up, so the remainder will probably be ridiculous. X cubed plus 5x squared minus 3x plus 14 divided by x plus 4. Okay? To divide these two polynomials one by the other. I may use synthetic division because this is 1x being added or subtracted to a number.
So it can be added or subtracted?
Yes. And you switch the sign when you go to the synthetic division. That's the
So
other way
you
to
would
do it.
switch that sign?
Yeah, here's what happens. First you draw your familiar extended L shape. Okay? Then you write these coefficients, and again you have to remember to put placeholders in for the zeros if there's a term missing, if there's not a term of every degree. So I would write 1, 5, negative 3, 14. When you put this 4 over here, as most of you remember, the sign does switch. It becomes negative 4.
Why the hell did you put the 4 there?
I'll show you in a second.
I draw this differently.
No, we did this last year.
Yeah, that's what I said. It's going to be familiar to everybody. Well, yeah, what you do is, and then you add, you bring down the first coefficient, and you multiply the number out here, in this case negative 4, by that first coefficient.
Which is negative 4.
And you put that here.
Then you added
Add these,
negative 1, multiply, negative 4.
and again multiply. Hang on, Brandon. Your participation right now is helping the people who haven't seen this before learn. So now it's negative 4 times this number, which again gets me negative 4. Add these together, I get negative 7. Negative 4 times negative 7
28.
gives me positive 28. Add these together and I get my remainder, 42, the meaning of life. Now, because you're always dividing by what's called a linear term, because if I graphed y equals x plus 4, I would get a line. So because I'm always dividing by a linear first degree term, your answer is always going to be 1 degree lower than whatever was on top. This was x cubed, so my answer will begin with some sort of x squared. What sort of x squared? The sort of x squared that has these as the coefficients of its terms. So my answer is 1x squared from this one plus 1x from this one minus 7. And then I have my remainder of 42, so that's plus 42 over
Can we get a long division as a rule?
x plus 4. Pardon?
Long division.
We could.
I actually like the long division better.
I did too when I was your age. It's really weird. Yeah, you and I think are right, Brad.
Why is it negative 4 and not 4? Because it's x plus 4, not x minus 4.
Correct. All I can tell you for that is it's a little bit like when you have x plus 4 as a factor, what is your 0? If I have x plus 4 equals 0, okay, what does x wind up equaling?
Minus 4.
Minus 4. If you're doing polynomial long division, you're dealing with factors. What some very brilliant mathematicians actually figured out a use for this is, here you're actually checking for zeros. Like if I get a remainder of 0, then this tells me that negative 4 was actually a solution to this. So what you're actually doing with synthetic division is you're checking for zeros, and if you get a remainder, it isn't one. Incidentally, your remainder is also, I'm not sure, I know I told you guys this, but I'm not sure you remembered as much. This also tells me that,
It's your, like when you have, are you saying like what the remainder would turn into?
Yes.
It's like with the synthetic, it's like with the long division where, for example.
well, hang on, actually that's not what I'm saying this time. It's, if I just had the top,
Oh, no, wait, it turns into a thing. So it's x minus 4.
okay, hold on guys.
these.
If, a couple of things I want to go real quick. Okay,
May I quickly go to the bathroom? Or is
let me say this real quick. Okay, this is important. Chris, what's up? Wait.
It's
There's one right
behind
there.
you.
It's behind me and wait. Okay?
It's right behind you, Chris.
Yeah, but it's electric, I don't have the noise. Wait. Okay? If I was wondering, okay, this was my top polynomial up here, okay? This also tells me this process, by the way, that f of -4 would equal 42. The remainder is also what you would get if you put -4 into the top polynomial. If you don't have a calculator, this can actually be a faster way than doing what is -4 cubed
Well, that makes
plus 5
sense.
times -4 squared. So those are the two best reasons I give you for why you switch the sign, is you're either testing for 0, or you're finding what f of -4 would be if your function is your numerator. So synthetic division serves three purposes: quick test for zeros, quick way to find the value of a function, and it's faster than polynomial long division for most people. It wasn't for me when I was in high school for some reason. I had a mental block or something.
Really?
And,
It's so easy.
But it only works if you have a linear term in the bottom that starts with +1. If I put a 2 here, it doesn't work. If I put an 8x cubed, it doesn't work. Yes, Drew.
If it was like a quadratic, like x squared plus another x and then minus
Huh?
1, you do factor it and get to that, and then do something else to get back to
If the directions were to, I need to find an actual example here. I'm not going to make one up.
Wait, can I go do it?
Yes, now you can. All right, sorry, thank you, Tina.
Oh, God, it's gonna be so much fun.
Yes, very quickly. The way math books will use this sometimes is, okay, here's the problem. That'll work well. Stephen, can you follow me to board number 2?
Yeah.
Okay, excellent. Okay,
What are we doing?
Drew,
Yes.
our test.
Are we going long division?
we're doing synthetic. Okay,
Don't we
Yeah.
teach long division?
Yeah, I know.
we did. You missed it. Okay, solve the equation.
Honestly.
Friday. Okay, solve the equation.
Test?
No, guys, stop.
Oh,
Wow.
Pay attention to this problem up here, please.
why?
Solve the